Okay, so we'll be discussing horizontal asymptote. So, when determining the horizontal asymptote, it is important to identify the degree of the polynomial in a rational function. So, for example, I have here a polynomial given as x raised to 4 plus 3x cubed plus 2x squared plus 5. So, in determining the degree of the polynomial, you just need to identify the exponent of the highest degree variable. So we have here the highest degree variable to be 4. Hence, our degree will be 4. Okay? So, in identifying the horizontal asymptotes, so you just need to compare the degree of the polynomial in the numerator and the polynomial in the denominator. So, if the degree of numerator is less than the degree of the denominator, the horizontal asymptote will be equal to 0. If the degree of numerator is greater than the degree of denominator, the horizontal asymptote, there will be no horizontal asymptote. And if the degree of the numerator is equal to the degree of denominator, the horizontal asymptote will be equal to the numerical coefficient of the highest degree variable in the numerator divided by the numerical coefficient of the highest degree variable in the denominator. So let's have an examples. So again, let us identify the degree of the numerator and the denominator and compare them. So for the degree of the numerator in y is equal to x plus 1 over x squared minus 1, at the numerator it is 1. In the denominator it is 2. Comparing the numerator and the denominator, it turns out the numerator is less than the denominator. Hence, our horizontal asymptote lies at the 0. Okay? So, next one, let's compare this one. If the degree of the numerator is 2 and the degree of the denominator is also 2, turns out that the numerator is equal to the denominator in terms of degree. Hence, we should get the numerical coefficient of the highest degree variable of the numerator and the denominator. For numerator, it is 1. And for the denominator, it is 3. So, this will be 1 over 3. Hence, our horizontal asymptote will be y is equal to 1/3. Okay. Next, the degree of the numerator in this third example is 2. And the denominator is 1. So, it turns out that the numerator is greater than the denominator. So, there will be no horizontal asymptote. Let's have more examples. So, we just would like to simplify first before we proceed to identification of the horizontal asymptote. So, this will be 8x minus 16 over x squared plus 3x minus plus 3x over x squared plus 3x. So this will be, arranging this one, this will be negative 9x squared. 8x minus 9 times 3x is 27x. So this will be negative 19x minus 16 over x squared plus 3x. So we just need to identify the highest degree, the degree of the polynomial in the numerator and the denominator. the numerator it is 2, this one, and the denominator is also 2. So this will be unequal degrees. So we need to acquire the numerical coefficient. So this will be negative 9 divided by 1. So our horizontal asymptote will lie at negative 9. Okay? So let's have another example. Second. So this is numerator is equal to 2. At denominator it is also 2. So this will be horizontal asymptote will be 1 over 3. So number 3, let's compare x squared plus 1. Numerator is 2, denominator is 1. So there will be no horizontal asymptote. So in if we have rational function wherein there will be no horizontal asymptote, typically this type of function will be having an oblique asymptote. So for example, so I have here x squared plus 1 over x minus 3. So it is obviously it does not have an horizontal asymptote. So because the numerator is 2 and the denominator is 1 and the numerator is greater than denominator, so no horizontal asymptote. So every time that we don't have an horizontal asymptote, there will be an oblique asymptote. So how we would find the oblique asymptote? So we just simply need to divide the polynomials. So this will be x minus 3 over x squared plus 0x. So it is important to arrange them in decreasing order. So, plus 1. So although the 0x does not appear on this expression, so it is implied that there is a 0x between them. So from x squared to x raised to 0. Okay? So it would be important for you to learn dividing polynomials. Okay? So you might want to review this topic. Okay, so x squared divided by x is x. X times x is x squared. X times negative 3 is negative 3x. So subtracting this will be 3x plus 1. So 3x divided by x is 3. 3 times x is 3x plus 3 times negative 3 is negative 9. So this will be 10. Okay? So for oblique asymptote, it is important to identify the quotient less the remainder. So we wouldn't need this remainder. So we just need this quotient less the remainder. Okay, so turns out this is the oblique asymptote. Y is equal to x plus 3. So I would like to find it in the graph how this y is equal to x plus 3 appears. So this y is equal to x plus 3 is in the form of y is equal to mx plus b, a slope-intercept form. So m is the slope and b is the y-intercept. So it turns out this y is equal to x plus 3. I have had 1 here. The slope of this equation is 1, which is represented as 1. and the y-intercept is positive 3. Okay, so I would like to plot this point. So m is 1, so it could be 1 over 1, or it could also be negative 1 over negative 1, and this is a rise over run. Okay, so I would like to plot first the y-intercept, which is on 3. So this will be the y-intercept. Okay, and the slope is 1 over 1, meaning rise. So we would like to rise positive 1 here, followed by run positive 1, meaning to the right. So here, so this would be the second point. Or if you would like to use this slope, negative 1 over negative 1, so rise negative 1 from 3, this will be negative 1 down here, and run negative 1 at the denominator. Run will be negative 1, which will be to the left. Okay, so the asymptote, the oblique asymptote, will be in the slanting orientation. Okay, so it will be on a slanting orientation. So this will be the asymptote, meaning there will be no graph of y is equal to x squared plus 1 over x minus 3 that will pass through this slanting asymptote. So let's have more example. So again, we just need to divide the polynomial. Okay? So x squared plus x plus 1 will be divided by x minus 1. So this will be x minus 1, x squared plus x plus 1. So x squared divided by x is x. X times x is x squared minus x. So this will be 2x plus 1. So 2x will be divided by x will be 2. 2 times x is 2x plus, I'm sorry, this will be minus 2. So this will be 3. So there will be a remainder of 3, but we don't need this one. We only need this quotient less the remainder. So this oblique asymptote will be equal to x plus 2. So how would you find that? So you just need to identify again this y-intercept, which is 2, and the slope, which is 1. So again, this could be 1 over 1 or negative 1 over negative 1, which is rise over 1. Okay, so b is 2, so it will be located here. Negative 1 over negative 1, so let's try negative 1 over negative 1. Negative 1 rise, so this will be down. Negative 1 run will be left. So this will be the equation of, or this will be the graph of the oblique asymptote.